So let's look at an example problem for conduction. So assume you have an industrial furnace wall that consists of a 0.25 meters thick brick. So if you look at this image, you have a length of the wall that is 0.25 meters, and assume that the wall's thermal conductivity is 1.7 watts per meter Kelvin. And so under steady state conditions, you have the inner surface of the furnace. So the inner surface temperature over here, T1, is 1250 kelvins, and the outer surface temperature is 950 kelvins. The question is asking you to calculate the rate of heat transfer by conduction through this wall section that is measured as having a height of 1.5 meters and the width of it is 2 meters. So I'd suggest you pause this video and try to solve it yourself, and then we're going to go through the solution together. Okay, so let's look at the solution together. So we know that this is conduction, so we're going to use Fourier's law to determine what the heat flux is into the wall, and we do that by using the Fourier Law equation, which says -1 multiplied by the thermal conductivity of the wall multiplied by the temperature gradient occurring inside the wall. And we know what the thermal conductivity is, and we know that temperature gradient is just the difference in the temperature divided by the length of the wall. So in this case, it would be 1.7 watts per meters Kelvin multiplied by the difference in temperature, so 1250 minus 950 kelvins over the length, which is 0.25 meters. This gives you a heat flux of about 2040 watts per meter squared. And so this is the amount of heat flux that is penetrating through the wall. Now you want to know what the heat flow is, and so you multiply the heat flux by just the perpendicular area, which is 1.5 meters times 1.5 meters of height times 2 meters of width. And so that means you have 2040 watts per meter squared multiplied by 3 meters squared. And so the total heat that is passing through this section of wall is 6,120 watts. And this is how you calculate the heat flow. Now, there's something that I want to cover because this is something that people might have in their mind. Thermal conductivity is a parameter that you search and get to use in your equations and analysis. Keep in mind that the thermal conductivity is also a parameter that's dependent on temperature. So when you search for thermal conductivities online, just make sure that you find a temperature that is representative for the situation that you're dealing with. So for instance, if you are looking at this scenario, we are dealing at a temperature range between 1250 Kelvin and 950 Kelvin. And so because the temperature range is not too far apart, you could look at an average temperature and find the thermal conductivity of the average temperature between the 1250 kelvins and the 950 kelvins. And it really depends on what you're trying to do. Sometimes when you calculate heat flow, you might want to err on the side of caution. And that sometimes means you want to use the more exaggerated number. However, in this particular case, a representative thermal conductivity number would be an average of both. And that's something that you'd see that is being applied in a lot of the heat transfer problems. This doesn't mean that the thermal conductivity is constant, but it just meant that whoever decided to use the thermal conductivity number assumed a representative average value to use. And you can also do a sensitivity analysis yourself. You could use the thermal conductivity of temperature at T1 and temperature at T2 and solve the problem twice, and you're going to realize that the difference in both answers are very minimal. And I'm just saying that because if you actually do this exercise, it helps build your intuition as an engineer. And this is something also very important. I don't want you to memorize things. I want you to build that right intuition. Okay, so now that we've looked at conduction briefly, we're going to look at convection and radiation. So I just like having this table that summarizes the governing law, the equation, and the different modes of heat transfer. So again, we said that the governing law for conduction is Fourier's law, and the equation is heat flux is equal to -1 multiplied by the thermal conductivity multiplied by the temperature gradient of that stationary fluid or of that solid. Now we're going to move to convection, and we're going to look at it in more detail in the next video. So without further ado, see you in the next video.